Hello and welcome to a new video. This is for middle school math using the Math UC Zeta curriculum. We are on lesson 14, so that's almost halfway. And we're going to consider it close enough because we are right now about to hit Christmas break. This is the last lesson we're doing before Christmas break, so get excited. We are multiplying decimals, and you may be thinking, wait a second, haven't we already been multiplying decimals? And you'd be correct. Essentially, this lesson just tries to bring it home, like that, we're multiplying decimals, we're good at it, and we're going to be successful with it. Basically, actually, they just have really, really big numbers, like lengthwise for us to multiply together. Not necessarily big numbers as in like 1,000, but big numbers as in lots of digits. So we're going to give this a try. We're going to start off here by warming up with a couple of kind of smaller ones so that we can remember what our rules are, and then we'll get into some bigger ones, and then we'll get into some word problems, which is everybody's favorite. That's sarcasm. Nobody likes word problems except that one kid. That one kid likes them, right? You know that kid, right? No, just me? Okay. All right, multiplying decimals. So pretty easy, straightforward one here, 3.2 times 4.5. So remember that when we multiply decimals together, it's exactly like regular multiplication, except that we have to think about where the decimal should go. So it's different than when we add decimals that we just drop down the decimal. It's that we have to think, okay, if there are however many decimal places there are in the two numbers combined, that's how many should be in our answer. So that's something we can figure out before we even do any multiplication. And I recommend that you do that because there's two kinds of issues you can have here. You can have an issue of where does the decimal go, or you can have an issue of not multiplying correctly. And so if we can figure out which one of those two you're messing up, well, I would argue that figuring out where the decimal goes is actually the easier part of this, because if we're multiplying wrong and we're multiplying wrong consistently, the only way to get better at multiplying is to practice, which I know that if you're not good at multiplying, one of the last things you want to do is practice. I get that. Another thing that's helpful is just really training yourself with multiplication tables to try to be able to do those quickly. So I guess with multiplying, there's also two things that typically go wrong. One is not knowing your multiplication tables. So looking at 5 times 2 and not always getting that right, that would be one issue. Another issue though would be remembering to like carry and just kind of the steps that we do, remembering to put placeholders. So there's so many places to mess up, basically, that as we're checking our work, it's important that you figure out if there's a pattern to what you're doing wrong, because if there is, then you should try to focus on getting that part right as well as all the other parts. So let's give this a try. 3.2 times 4.5. So I'm going to go ahead and decide where the decimal is right off the bat here. So you think about it too, and let's see if we're on the same page. We've got one decimal place because we're counting how much is to the right of the decimal. And then we've got one decimal place. So 1 plus 1 is 2. Our answer is going to have 2 decimal places. I also want to comment on the way the Math UC workbook writes out their problems, that if you don't like how they're writing out the problems, then write it out on a different sheet of paper might actually be super helpful, like on notebook paper, so you have lines that you can use, or just write it out to the side, because if you don't like how they're choosing to line things up and that's throwing you off, then there's a really easy way to fix that, which is to write it down yourself. Okay, 4 minutes in and we're about to actually start this problem. 5 times 2 is 10, so I write down the 0 and I carry my 1, and then I do 5 times 3, which is 15. But I look up here, I've got a 1 that I'm carrying. 15 plus 1 is 16. So I write down the 6. There's not anything else to carry to, so I also can write down the 1. Before I go to the next step, one of the things I do is mark out that 1 I carried. Then I come down and I say, the next line always has a placeholder of 0. Then I go through and I say, okay, let's multiply by 4. 4 times 2 is 8. And 4 times 3 is 12. And since I don't have any more numbers, I don't need to carry the 1, I can just write it next to it. Now what we're doing is adding our columns. So 0 plus 0 is 0. 6 plus 8 is 14. Carry your 1. This is another place that's easy to mess up. especially if you're not doing a good job of writing your work neatly so that you can tell where your columns are. So that's another thing you might need to work on. 1 plus 1 plus 2 is 4. And then nothing plus 1 is 1. So we're getting 1440. We've said our answer should have 2 decimals, so we always start from the right and count 2 decimals to here. This should be 14.4, and you can either put the 0 there or you can actually leave it off. Any zeros at the far right don't have to be written. They can be, but they don't have to be. This would be our answer. And then we could just double check and say, okay, if I estimate this, I've got about 3 times about 4, or about 3 times about 5, depending on how you want to round that, which is somewhere between 12 and 15, which, because of where we put the decimal, we got 14.4, which is in between 12 and 15. So I feel pretty good about our answer. It's super easy to check this with a calculator. Maybe you want to have a parent or an older sibling check it for you with a calculator. But before you go and like redo it, have somebody check it for you and say, okay, if it is wrong, is it just that I put the decimal in the wrong place? Okay, that's something that can be fixed. If it's something else, like you got a completely different number, like 13.2, then it's probably a multiplication issue. Try reworking it again, paying extra careful attention to what you're doing along the way. Maybe have that parent or sibling or friend sit with you and talk out loud to them about what you're doing. Hopefully they can help you catch where your mess up is and then help you just to get better at not making those mistakes. We're going to do a second warm-up, so this time we've got longer numbers. This is going to be fairly annoying how big these numbers end up being, like not size-wise necessarily, but length-wise. So let's decide how many decimals here. We've got 2 decimals, and then we've got 2 decimals. So that means that our answer is going to have 2 plus 2, which is 4 decimals. So let's do some multiplying here. We're going to start with the 2. 2 times 3 is 6. 2 times 2 is 4. 2 times 1 is 2. 2 times 5 is 10. Okay, then we put a placeholder. We don't need to mark out anything that we carried because we didn't carry anything. Now let's do 8. 8 times 3 is 24. Carry our 2. 8 times 2 is 16. Plus 2 is 18. So I'm going to write down 8 and carry my 1. 8 times 1 is 8. Plus 1 is 9. And 8 times 5 is 40. Now for this next one, when we do the 7th, we need 2 zeros for placeholders. And let's mark out these that we carried with. 7 times 3 is 21. So we put down 1, carry our 2. 7 times 2 is 14. Add 2, which gives you 16. So 6 and then 1. 7 times 1 is 7. Plus 1 is 8. And 7 times 5 is 35. Well, look at how long this is. Now we're going to add in our columns. So 6 plus 0 is 6. 4 plus 4 plus 0 is 8. 2 plus 8 is 10. Plus 1 is 11. So write down 1, carry your 1. 1 plus 0 is 1. Plus 9 is 10. Plus 6 is 16. So 6, carry your 1. 1 plus 1 is 2. Plus 0 is still 2. Plus 8 is 10. Carry. 1 plus 4 is 5. 5 plus 5 is 10. Carry our 1. 1 plus 3 is 4. What a long number. We said our answer needs 4 decimal places. So 1, 2, 3, 4. This is 400.6186. So I said if we have zeros at the end, like on the right side, you can drop them, but that only is if they are like after the decimal place and are at the far end. So like we can't get rid of these 2 zeros in 400 in case that wasn't already obvious to you. And if we think, okay, this is essentially like saying, 50, we're estimating here, 50-ish times 8-ish is 400-ish. Well, we got something really close to 400 actually. So this looks like, if it's not completely correct, it looks like it's pretty close. So there's our answer. So our new content for the lesson, there's really not anything different. It's just that our problems are going to be longer. You're going to see lots of numbers with 2 to 3 decimal places, so that you're going to end up with a lot of decimal places and a lot of multiplication. So this definitely might be something that you want to do a couple problems and then take a break. Do a couple problems, take a break. I don't think there's as many problems because of how long they are, so that's nice. So we want on example 1 here to do 4.019 times 0.321. Let's figure out how many decimals we're going to have. So this has 3 and 3. 3 plus 3 is 6. So our answer is going to have 6 decimal places. All right, 1 times 9 is 9. 1 times 1 is 1. 1 times 0 is 0. 1 times 4 is 4. Let's put our placeholder. Then multiply by 2. 2 times 9 is 18. Carry our 1. 2 times 1 is 2. Plus 1 is 3. 2 times 0 is 0. 2 times 4 is 8. Okay, let's mark out our 1. Put 2 zeros now. And then multiply everything through by 3. So 3 times 9 is 27. 3 times 1 is 3, plus 2 is 5. 3 times 0 is 0. 3 times 4 is 12. Okay, what's that? 9 plus 0 is 9. Ooh. 1 plus 8 is 9 plus 0 is 9. 0 plus 3 plus 7 is 10. So drop our 0, carry our 1. This is happening, I feel like this happened on the last problem. 1 plus 4 is 5, plus 0 plus another 5 is 10. Carry our 1. 1 plus 8 is 9, plus 0 is 9. Then there's nothing to add with the 2 or the 1. So we need 6 decimal places. So counting from the right side, we got 1, 2, 3, 4, 5, 6. So this answer is 1.290099. Those zeros in the middle are important. It's only if they're at the end on the right side after a decimal place that we can drop them. This looks like our answer. Now if we go back and look at what the problem was, this is about 4 times 0.321. So the fact that we're timesing by something less than 1 is why our answer is actually smaller than the first number, because this is actually kind of like us saying, what's 32.1% of 4.019? Well, that implies that we're taking part of the 4.019, and that's why we're getting a smaller number. So hopefully that makes sense. It can be a surprise sometimes when we multiply and get a smaller number than what we started with, right? But that's what's happening here, is essentially we're saying I only want part of the 4 that I'm starting with, so I get a smaller number. And again, this is long, there's a lot to it, there's a lot of places you can make mistakes, so try not to get discouraged if you are consistently not getting it right, especially if you're getting close but not getting it right. It's just going to take practice and even just some maturity, honestly, to get better and better at these so that you're consistently getting them right. Example 2. So this is a case where if you don't like how it's lined up, you should rewrite it. So the way I learned to do multiplication was to always line them up on the right. And so if that's what you want to do, then we would start off actually by rewriting this so that they're lined up on the right. If, however, you like it better with the decimals lined up, that's fine too. Just know that you've just got to keep track of where things go. The rest of the work actually can look exactly the same, no matter which way you line these up. So let's see, we've got 3 decimals and 2 decimals, so our answer should have 5 decimals. So let's do this. 2 times 5 is 10, carry our 1. 2 times 0 is 0, plus 1 is 1. 2 times 0 is 0. 2 times 2 is 4. And 2 times 1 is 2. Mark out our 1, put our placeholder, and then multiply by 3. 3 times 5 is 15, so write down 5, carry our 1. 3 times 0 is 0, plus 1 is 1. 3 times 0 is 0. 3 times 2 is 6. 3 times 1 is 3. Now we've got to multiply through by 1. So we put 2 spots for our placeholders and then do 1 times each of these. So it basically actually just means we write down this number again. 1 times 5 is 5. 1 times 0 is 0. 1 times 0 again is 0. 1 times 2 is 2. 1 times 1 is 1. And then we're going to add our columns together. So all zeros here add to be 0. 1 plus 5 is 6, plus 0 is still 6. 0 plus 1 plus 5, 6 again. 4 plus 0 plus 0 is 4. 2 plus 6 plus 0 is 8. 3 plus 2 is 5. 1 is 1. So 5 decimal places, starting from the right. 1, 2, 3, 4, 5. This is 15.8466. You can either write the 0 at the end here or leave it off. And that 0 was important for us accounting for our 5 decimal places, but doesn't actually add any value necessarily to our answer here. So a quick check, 12-ish times 1-ish would be 12. We did get something that's close to 12, so that's a good sign. Let's see. I checked my answer with the calculator. It looks like it's correct, so there we go. We do have word problems at the end of our workbook pages, a couple on each, I think, at least A through C or D. So a couple of tips here. First off, most likely our problems are wanting us to multiply two things together because we're talking about multiplying decimals. Definitely we shouldn't be dividing because we haven't actually talked about how to divide decimals yet. You may be able to come really close to being able to divide decimals, but there is some trickiness to it and we haven't done it yet. So it shouldn't be dividing. Most likely it's multiplying. The other thing is they could put percents in our problems, and so you need to remember to change percents to decimals. You could change it to a fraction, but in this case it's more likely to be helpful to change it to a decimal before you multiply. So that's moving the decimal over 2 places so that instead of having like 30% you would have 0.3, or instead of 56% you'd have 0.56, right? I'll write that down. So 30% changes to 0.30, or something like 56% would change to 0.56, or 150% would change to 1.50. So things like that might be helpful. So let's check this out. Example 3, you decide to check that the gas pump is calculating how much you should pay correctly. If the price of gas is $2.97.9, which I guess I should have put per gallon. So you're paying that amount per gallon, and you fill the gas tank with 12.315 gallons, what will the total cost be? So we need to multiply these two numbers together to figure out what our cost is. Now, we generally write the longer number, not necessarily bigger, but longer number first, so 12.315. And see if that makes sense to you, by the way, that multiplying is what we should do here. We filled up our gas tank with 12 gallons and a little bit more, 3.315, and this is how much it costs for each gallon. So when we have a cost per something, we multiply to figure out what the cost will be based on how much we're getting. I'm not going to write the dollar sign down because I feel like it gets in the way. I'm going to write 2.979. And this will be a little annoying since we've got 9 and 7 and 9 again to multiply by, but I think we can do it. How many decimal places should we end up with? Think about that and write it down, and we'll talk about it later. 9 times 5, 45. Carry our 4. 9 times 1 is 9, plus 4 is 13. 9 times 3 is 27, plus 1 is 28. 9 times 2 is 18, plus 2 is 20. 9 times 1 is 9, plus 2 is 11. Now let's mark these out, write down our 0, and then do it all again, but with 7. 7 times 5 is 35. 7 times 1 is 7, plus 3 is 10. 7 times 3 is 21, plus 1 is 22. Write down our 2, carry our 2. 7 times 2 is 14, plus 2 is 16, so 6, and carry our 1. 7 times 1 is 7, plus 1 is 8. I'm running out of room, so that's not fun. Let's see, put 2 zeros here. Do it by 9. Now, this should actually end up being the exact same as what we got from 9 earlier. It's just shifted over 2 places. So we should get this 110835 again. So we can multiply it again, or we could just write it down. Just make sure you line it up correctly. And also that you pay attention to the right thing to copy. We're copying 5, 3, 8, 0, 1, 1. Now we need 3 placeholders. 1, 2, 3, and we're multiplying by 2. 2 times 5 is 10. Carry your 1. 2 times 1 is 2, plus 1 is 3. 2 times 3 is 6. 2 times 2 is 4. 2 times 1 is 2. This is so long. There's so many places that we could mess up. 5 plus 0 plus 0 plus 0 is 5. 3 plus 5 is 8, plus 0 plus 0, still 8. 8 plus 5 is 13. Write 3 down, carry your 1. 1 plus 2 is 3. 3 plus 3 is 6. Oh boy. 1 plus 6 is 7. 7 plus 8 is 15. 15 plus 3 is 18. 1 plus 1 is 2. 2 plus 8 is 10. 10 plus 6 is 16. 1 plus 1 plus 4 is 6. 1 plus 2 is 3. Now, how many decimals did you say it needed? If you said 6, you are correct. So starting from over here, 1, 2, 3, 4, 5, 6. That was really poor moving the decimal on my part. Sorry about that. So this is 36 point. And keep in mind that this is money. So we're going to round to the nearest cent here. Okay, so since that's a 6, it's going to go up. This is $36.69. That's what it should say on the gas pump for our cost. It's okay if you're having some trouble getting through the whole multiplication and addition and all that stuff without making any mistakes. We just hopefully get better and better at it as we go, as we practice. Hopefully by the end of doing the stuff in lesson 14, you're doing better than at the beginning. Unless you're just messing up because you're getting super frustrated about how long they are. That could make you do worse. So try not to get frustrated. Take a deep breath, have a drink of water, and just try your best. Example 4. So we've talked about the metric system some this year, but there are ways to go between the metric system and the customary imperial, I don't know what system it is, the United States system of obstinance. And so here we have, there are 2.54 centimeters in an inch. How many centimeters are there in 5.125 inches? And you may be thinking, why'd you pick such a random decimal of inches? But 0.125 is actually an eighth, and most rulers divide inches up into either fourths or eighths or even sixteenths. So that is actually something that you could get as you're measuring something. You could get 5 1/8, which is 5.125. Let's change it to centimeters. So again, this is a case where we're multiplying. If I have 5.125 inches and I want to say each of those individual inches is worth 2.54 centimeters, then I'm multiplying. So there's 3 decimals and 2 decimals. Our answer should have 5 decimal places. And let's go through and do this. This might be a good time for you to pause the video, try it yourself, and then start it back up once you have an answer or once you're stuck so that you can see how it's going. Okay, 4 times 5 is 20. So write 0 down, carry our 2. 4 times 2 is 8, plus 2 is 10. Write down our 0, carry our 1. 4 times 1 is 4, plus 1 is 5, and 4 times 5 is 20. Write down our 0 for our placeholder and mark out our carries. 5 times 5 is 25. 5 times 2 is 10, plus 2 is 12. Carry our 1. 5 times 1 is 5, plus 1 is 6, and 5 times 5 is 25. So 2 placeholders now. 2 times 5 is 10. 2 times 2 is 4, plus 1 is 5. 2 times 1 is 2, and 2 times 5 is 10. Let's add our columns. So all zeros add to be 0. Just 5 plus 0 plus 0 is 5. 5 plus 2 is 7. 6 plus 5 is 11. 1 plus 2 is 3. Plus 5 is 8. Plus 2 is 10. 1 plus 2 is 3. And 1 goes down here. Went 5 decimal places. So 1, 2, 3, 4, 5. This is 13.01750 centimeters, because we started with inches. Our goal was to get centimeters. Does this make sense? We've got about 5 times 2.5, so it should be something that's between 5 times 2, which is 10, and something that's and 5 times 3, which is 15. It should be a number between 10 and 15, which is what we got. And we don't actually need the 0 at the end. I just realized that I wrote it on this one without even thinking. But this is our answer right here. So I know word problems can seem really frustrating. Hopefully these aren't too bad, because you at least can be 95, if not more % confident that what you should be doing is multiplying the numbers they give you together. Thanks so much for watching. This has been another Math UC Zeta video. Hopefully you like it. If you do like it, leave me a like. And in fact, do you see I'm wearing a Star Wars Christmas sweater? So that's just another reason that you might decide to like the video, because I'm a really cool person that has a really cool Star Wars awesome Christmas sweater. And I hopefully will see you again virtually after the new year. Have a great Christmas or holidays in general, and I'll see you later in the next video. Bye.